Hello everyone, it's me Murli. In my previous video, we learned how to use notebooks on Microsoft Fabric, and we have introduced our use case called grocery stores. Now, in this video, we'll discuss how to do data preparation for product entity. Okay, so in the previous session, what we have seen is how to convert the PySpark, the Python list into a PySpark data frame. So quickly, we'll do a recap. So this is a simple Python list. We have created a schema for it, and then we use the data and the schema to convert into the PySpark data frame. And once after we get into a data frame, we have given a name to the temporary view as Fabric product temp view, and then we used in the Spark SQL something like this: select star from that particular temporary view. This is how we can convert a simple Python list into a Spark data frame. We use this technique to create all the data sets which are required for the grocery stores. To begin with, we'll start with products. As we all know, we buy lots of products from the grocery stores, and these are the list of products which I got from internet. And these are the different products, and these are the product categories. These are the vegetables, something like this. So I created it as a Python list. I declared it as a Python list, and then I run that. If you want to run, you will say Shift Enter. So when I said Shift Enter, it executed. Then I created a schema for it. The first column is called product category, second column is called product name, and I run that. So I got the data frame, I printed the schema of the data frame, and this is how the schema looks like. And I got a temporary view for that particular data set. I got the temporary view, and when I run this is how you see the data, the product category and product name. Now, from this product category and product name, I would like to extract only the product categories into one file. So the reason why we want to do like that is, assume that, just think the scenario in this way, like for our Microsoft Fabric, we get the data from different data sources, and our source systems, they send the data in the way how they store. Assume that this is how they store the data in their systems. Now we got product category ID and the product category. So we got the distinct list of product categories, and this is a product category ID, and I have written a simple select statement. If you observe this internal one, I'm using select distinct of the product category, which is here, this one, from the temporary view. And I made it as an inline view. That's why I have put them in the brackets. And on top of it, in the select statement, I call this particular column product category, and I have given a product category ID, some sequence numbers. Whenever you want to just generate a sequence of numbers in a select statement or in the temporary view, you can use this technique, like row number over partition by one, order by one. We'll understand what this partition by one, order by one, row number, subsequent sessions. But for now, just use this particular technique to generate some sequence of numbers like this. So we got product category ID and product category, and whatever this select statement is there, we have run that in the Spark SQL. Always remember, we run this sort of select statements as part of our data analysis. And once after we are okay with our data set and we are satisfied with this output, then use that select statement in a Spark data frame. And I took the data, that select statement, converted into a Spark data frame, and I have given another name to that, called product category temp view. In my next step, I'm going to generate a CSV file. There are various ways we can generate a CSV file from the Spark data frame or any Spark table. This is one of the way which I like it most, because if the data set is not so huge, this is a very good technique. So I have created a simple function for that. You can use it. And what this function is doing, like I imported the necessary libraries and I defined a PySpark, the Python function. To this Python function, I'm passing a data frame, source data frame, the folder name and the file name where it has to generate. I'm declaring here a format of the timestamp which has to be suffixed to the file name. So the format what I have chosen is just YYYYMMDD format, which is HS24 MISS. And that's what is this format. Then in this statement, I'm converting all the columns of the source data frame into the string type. The reason why we need to convert them into a string type is, in my next step, I'm going to convert this data frame output into the pandas, the Python pandas. Because pandas has a function called toCSV to generate a CSV file. This is a simple technique which I have used to generate the CSV, and in my past I did this. It really worked well. Then I use these variables inside here, the folder name, file name, and the current timestamp value. I'm using a delimiter called comma with, and please set this index equal to false, otherwise you will be getting an additional column in your final data set with the index column with just 1, 2, 3, 4 some numbers. We don't want this. We are already generating in our select statement. And header equal to true makes get the column heading in the CSV file. Okay, so we created this particular function which generates a CSV file. We pass these parameters here, the source data frame, and in this place we used a path of OneLake. So from where I got this path of OneLake, if you expand this Lakehouse Explorer, that's where here we got files, because the Lakehouse contains tables and files. And in this, if you click on these files and just get copy ABFS path, you copy that ABFS path and you paste it here. So here it is showing some randomly generated something with onelake.tfs.fabric.microsoft.com, and it has generated something here and the files. So that's what we are interested in, is these files. Under that, because we are generating some files, I want this file to go into a directory called inbound, and within this directory it has to go into product category, and the file name I want it as a product category. It has to start with product category. Of course, in the function we are suffixing that with some timestamp, but here this is how it should look like. Now let me run the data frame, shift enter, and then this function, I run this. After generating this, if you click on the files and refresh, you can see here inbound, you can see a product category, another directory. When you click on this product category, you expand this and you see the file which is generated. The file which has generated is product underscore category with a timestamp in YYYYMMDD format. This is HS24 MISS format .csv. Now what we do is we go to the Lakehouse. In the Lakehouse, you can see under this Lakehouse, under these files, just refresh, click on this, product category, and you can see here a CSV file is generated. So by the way, how to come into this Lakehouse is when you click on this One Lake Data Hub, when you click on this My Workspace, in the My Workspace, you see your Lakehouse, click on this Lakehouse. That's how you come to this place. Now, we have seen how we can generate the product category. In the similar way, now I will generate the product data. So I created a query, a simple query. I executed it, and I have seen the output, how the product data looks like. It has product ID, product category ID, and product name. This is how the data comes from the source in this way. And I use the select statement in my next data frame. I created a temporary view like this, and then generated a CSV. So this CSV, I used the data frame df_product. I used the folder name product under inbound, and the file name should prefix with product. Again, we'll come back to Lakehouse, come here, we'll just refresh it. We got product, click on the product, expand this, and you got this. Now you go to Lakehouse in another tab, just refresh it. You can see product and the product, and this is how it has generated a CSV file for us. If we go back to generate the product price data, so I have created a simple query to show that each product, for every year there is a difference in the product unit price. So what I did, I created the first set of data set, the product ID, and I am actually using a simple rand function with a seed of 1 to show that the output is same for you and as well as for me when you see rand of 1. Because if I don't use 1, if I simply use rand of bracket open and bracket close, my output looks different to whatever you run. So for your run and for my run, if I want to get the same values, I use this particular seed 1, and I multiplied with 10 because it gives you a decimal value with 0 point something, and then I multiplied with 10, rounded it to 1 decimal, and at the end I want my price value to be is 15, 25, 35, something like that. So I generated it, and the price effective start timestamp, the very first time when I am actually setting up in my source system, here I have set it as 1900-0101 as the very first beginning one. And then in 2019, the prices got changed. 2020, again the prices got changed. 21, 22, 23. And I put a union all set operator to get the output of all these, and then I use something like this. So here I got the product ID, which is inside product ID, and the unit price from here I got, and I created the effective timestamp. I converted into a specific format, YYYYMMTD space HHMMSS. So if I don't do this one, I get the output in I'll quickly show you how output looks like. Let me run this and show you. So you see this output with T and Z like this, but I don't want the output to look something like this. So I got this select statement ready. I use that select statement in the data frame, and this data frame I given a name as product price temp view, and I'm generating it. Now let me run this data frame and generate the CSV. I generated the CSV. We'll come back here, refresh it. We got the product price. Click on the product price, and you can see here the product price file is generated. We'll go to the Lakehouse tab, and then we do the again same thing, refresh, product price, and you can see the product data. See, we got all the data with just few clicks and a small piece of code. Thanks for this session. We'll wrap it up now. We'll catch up in the next session. Thank you.